Hi everyone. So in this video, we will be discussing the limiting reactant and excess reactant lab. In this lab, I just want you to think big picture. We are essentially completing a double displacement reaction, and this is important for later when we start talking about certain terms, notably precipitate. You're going to see that repeated. Um, but this precipitate is forming from us combining copper sulfate and sodium sulfide, and it's forming copper sulfide. So the copper sulfide is a solid that forms, and these two starting reactants or reagents, those are synonyms for each other. They are aqueous solutions. So we're combining these two in different ratios so that sometimes the Na2S will be the limiting reactant and sometimes it'll be the copper sulfate. So we're going to have some standard solutions that will allow us to know, um, depending on what you observe, which one is which one is the limiting reactant, whether it's sodium sulfide or copper sulfate. So as always, you are going to head over to your copper, to your, wow, to your Hayden McNeil course lab site. You are going to open up your lab 8, the limiting reactant and excess reactant. And by now you probably got the point. Can't talk today. Um, you go to the little green notebook icon, and that takes you to the two pages. The intro page is the first page, and then the second page has the link and the procedure, the actual instructions for completing both experiments 1 and 2. So there's part 1, and then there's part 2. And then you record everything on this handout for your data collection. Some notes and tips. As always, make sure you're using the correct chemicals, correct concentrations. You never know, you may have different solution concentrations or chemicals that sound alike, right? It could be sodium sulfate and sodium sulfide. That sounds very similar. So make sure, and the name looks very similar. So make sure that you're using the right one. Now, after experiment 1, you're going to have 2 test tubes which show you excess of copper sulfate, and the other one shows you excess of sodium sulfide. Keep these, make sure to keep these. I also recommend you labeling these. So once you have this test tube, you can call it standard 1, for example, or and for the second one, you can call it standard 2. You can call it whatever you want. If you want to write on there excess, copper sulfate, or if you want to write excess sodium sulfide, however you would like to, keep this organized, manage this, that's up to you. It would be the same if you were completing this in person. You would put either tape on your beaker or test tube, and you will write on there, right? Standard 1, um, or standard 2, or you can write whatever it is that would keep you and help you be organized. And then you'll complete the lab, scan it, upload it, usual. Now, how does the data collection portion look? So you have experiment 1, where you are just recording some volumes. Now, in addition to that, you are also recording some qualitative data. So quantitative data always is, numbers, right? Numbers with your units, and then qualitative is, observations, color, presence of a participate. So this is your qualitative data. So this is important as well because this is how you determine and how you use your standards to determine your limiting reactants in experiment 2. Now, before I head over there, another thing I recommend writing here, and this I know I didn't explicitly add it, as something you record. I also recommend you writing down the concentration because you'll see how we use this in just a bit. The concentration of this copper sulfate solution and this sodium sulfide solution. You can just jot it down, maybe here as an extra piece of data. because we will use this later on. And by concentration, I mean the molarity, right? Okay, now let's move on. So in experiment 2, um, what you can think of these trials as, they are different ratios, different combinations. You just have different amounts of copper sulfate and sodium sulfide that you're mixing together. So they're like little different mini recipes. And you're seeing how much product you form. So to get this mass, what you're going to be doing is weighing the product. Now, of course, whenever you're weighing this out, you'll see that you have this precipitate inside of a test tube. So the test tube isn't part of your reaction. So you have to subtract out your test tube from your total mass to get the mass of a precipitate, right? So let's say I have a scale, right? Um, and it has the numbers right there and everything. And I want to weigh my cat. My cat is not going to stand there on the scale nicely and sit there still until it, figures out the weight. So what I'm going to do instead is I'm going to weigh myself first, right? So I come first. I determine, blah, blah, blah pounds. And then second, I'm going to I'm going to carry the kitty, right? My kitty. Pretend that's a nice little drawing. And I'm going to weigh myself and the cat together. Now, how do I get the weight of the cat? I'm going to subtract the two. So subtract the second from the first away from the second, subtract that away, and that'll give you the pounds for the cat. So that's what you're doing here, right? You have your test tube. I was a test tube. I was the thing that helped us weigh this out. So remember to subtract that out to get the precipitate. Now, you might be thinking, what is the precipitate? And if you do the experiment, it would make a lot more sense once you do it, because you're like, oh, it's a solid. This is a double displacement reaction that you're completing, right, which I mentioned earlier. In this reaction, what you end up getting for products is a precipitate and some spectator ions. These are going to stay in solution. This right here is a solid. That's how we know it's a precipitate, okay? And you're starting off with solution 1, solution 2. They're aqueous solutions. So that's what we mean by precipitate. That's what's forming, okay? Here, for appearance, this is purely qualitative. You're just observing. So this is an observation. And then finally, for this, you are comparing to your standard, right? So what I'm writing right here in these boxes, I'm telling you where this is coming from, where these, what you're recording is coming from. This isn't what you're writing in your data, okay? So for your masses, you would have a mass with grams. For your appearance, you would have some sort of color appearance that you're, filling in. And then here is where you are determining, you're going to write out this one, or neither, okay? So that's what your answer should look like. That got a little messy. Okay, so that's where these pieces of data are coming from. Oh, and then I wrote right here, remember to subtract out the mass of the empty test tube. So that's the point I was trying to make with the weighing and the cat. So that's what that's about. So follow-up questions. Which combination of amounts, copper sulfate and sodium sulfide, has the correct stoichiometric amounts? So by this we mean, which one is the most ideal? Which one has no leftovers? And I'm not, I'm very lenient with kind of open-ended questions like this. So just, write out what you think is the best answer. As long as I see you did the work, you wrote out the calculations, you're good to go. And then here, which combination of amounts gives the maximum amount? For this one, you will have to refer to your calculations to determine which one gives the most product, your solid, your precipitate. So solid just another way of saying precipitate, and in addition, another way of saying product, because your product is what's forming, right? Your solid. So how would your calculations look for this um, lab, right? I have a space where you can do your calculations. Now, you can always make this table bigger, not this table, this area bigger. It's just a little shape, so you can extend it, or you can add another page or a scratch paper, like notebook paper, and you can do your calculations on there. That's completely fine as well, as long as you include it. So before we start calculations, I want to head over to the lab site to show you, what's going on. So you log in, you access the lab site, and then you go to lab 8, green notebook. So as always, starts off very broad, the intro, the background. So we start talking about moles, about ratios, about stoichiometry itself, right? You've learned about this in lecture. And then we go into limiting reactants. So hopefully by now this is review for you, but limiting reactant is the one that stops your reaction because it got entirely used up. And then excess reactant, you have it left over. So both of these, depending on how much you're starting off with, can change, right? You can have the limiting reactant be, for example, in this case, you can have it be magnesium in one situation. In another situation, depending on the amounts, you could have HCl. So it all depends on what you're starting off with. So it shows you general idea of calculations, and we're pretty much going to follow the same thing, except because we're starting off with a solution with a certain concentration, we have to kind of add an extra step at the beginning. So that's what I'm going to show you here in just a second. So in terms of the lab itself, there's not much too special regarding, what you're performing. You've done everything. You've recorded volumes. You've poured solutions from one to another. You have measured masses. So you've done everything. So I have complete faith in everyone for doing the actual lab. The only tips I have is, labeling. So to label, you can double click your test tube. And by the way, this test tube, it just has, it has one of your plain materials in here. It has your copper sulfate in there. This is not your standard. I just labeled it to show you, okay, you double click it, you can label standard one and click done. And then you see it has a label. See, in comparison to just leaving it as large test tube. Like I said, this is not how the standard may actually look, okay, because I didn't go all the way to the standard just yet. But just an FYI regarding labeling. Another cool thing that I wanted to show you, you're probably already aware, but if you would like to see the actual list of materials, because for example right here it has everything on the shelf, but it doesn't show you like a list. If you put this as a half screen, it will show you, like if you click materials, it will show you everything listed out. So I really like this feature. Same thing for containers, right? You can see everything all at once. Same thing here. So just wanted to give that quick, tip, because you learn something new every day. Okay, so experiment 1, you're preparing the test solution. You are preparing the test standards. It's the easy part. And it also kind of gives you a tip at the very end. Double click on each test tube and label. I definitely recommend this so you don't lose track of which standard is which, because if not, you're going to get lost and then you'll have to start all over. Okay, so experiment 2, this is where you're testing your different ratios. So this is the good part. Now what I want you to really take note of is these concentrations, because this is how you get started. So the concentration and the volume. Let's see. Concentration 0.1 for sodium sulfide, and volume. So notice that they're both 0.1. So keep that in your mind because I'm going to show you an example of how to get started. And then that's pretty much it. From there, you will determine your limiting reactant. So let's head over to our lab handout and I'll show you how to do this. Everything else is just what you're doing for the rest of everything. You have to decant, so be careful with that. And then you're weighing to get your precipitate. Okay, so now we're back to the lab handout. Now remember, I told you to kind of write down an extra piece of information just for your own sake so you don't have to switch back to the lab so much, to the lab website, to write down the molarity of your CuSO4 and your Na2S. So keep that in mind. That's what I'm referencing right now when I'm going to write out the molarities. And also another thing that's very important is that you balance this equation. I want you to balance it, so I'm not going to balance it just now. But whenever I'm referencing coefficients, this is what I mean. It's whatever you get in order to balance this, okay? So with that in mind, let's go ahead and get started. So we're starting off with our 0.1 molar Na2S and 0.1 molar CuSO4. So let's look at trial 1. Trial 1, we mixed 5 ml of CuSO4 and 1 of Na2S. So 5 ml, should have flipped these around, but it's okay, and 1 ml. Now, how do I even get this started? What you have to do is convert everything to moles. Moles is what gets you wherever you need. If you've seen the mole map from chapter 4 about stoichiometry, then you know what I'm talking about. And that's what I'm talking about here. So I'm going to get us started. 0.1 molar. What can we do with this? Anytime you have a molarity, you can split it up so it can look like a conversion factor. Molarity always means moles over 1 liter. So what I can do here is split it up into 0.1 mole of, for example, Na2S divided by 1 liter of solution. Now that we have this is your like golden ticket that gets you everywhere because now you have moles, right? You can work around that. But notice you have liters, right? I have liters right there on the bottom. So what I need to do is convert my ml for both of these before I get started into liters. So that's what I'm going to do here. 1 ml. And I'm going to write it out all as one long calculation because I really like doing that. So 10 to the third ml give me 1 liter, right? 1,000 ml give me 1 liter. Remember, mLs are tiny, liters are bigger. So you need a bunch of mLs to get one liter. So now we're at liters. And now what we can do is set up this conversion factor that we, basically extracted out of the information we had. So luckily for us, it's already set up so that liters cancels out. So that's what I'm going to do. I'm going to write it exactly how it was written right there. Liters. 1 liters. That's what we're referencing here, solution. And then 0.1 mole Na2S. Now, where do we go from here? Now we're at moles, right? Because ml canceled out, liter canceled out. So now we're at moles. This is the part where you have to use those coefficients that you found for the balanced equation. You are going to set up, this is a blank that I have left for you here. The blank is because you need to balance it and find those coefficients. But whatever coefficient you get in front of Na2S in the equation, that's what goes here. Mole Na2S and then mole of your product. So your product, just to refresh for us, is your CuS. That's your product. That's what you're weighing. That's your precipitate. So that's what the ratio that we're looking for here. CuS. From there, you have moles of CuS. Now, how do we really confirm which one, mathematically, okay, quantitatively. How do we confirm quantitatively which one is the limiting reactant? You're going to have to take this 2 grams. So you are going to find the molar mass of CUS, and I'm going to leave that for you here. That's also a blank right there. You got to add up the masses of the atoms. Um, and that's CUS, big S. This will give you grams of CUS. So you're going to get a number here, right? And it's going to give you grams. You're going to do this exact same process. You saw how we did it for Na2S. Yeah, I was getting confused with CUS. You saw how we just did this for Na2S. You're going to do the exact same thing all over for 0.1 CuSO4 for the 5 ml. So you're going to start off with the 5 ml, and I'm not going to write it out, but you're going to start off with the 5 ml, and you're going to continue on the exact same process, and you're going to get grams of CUS. Once again, a different amount, but you're going to end up with also grams of CUS as your, unit. So what's the point of this? You can think of this like a test. One of these reactants, these are both reactants, your starting reactants, are going to give you less product. One of these are going to give you less product. That's another way of saying one of these is limiting the reaction. One of these is preventing, as much CUS from forming. So one of these is your limiting reactant. Whichever one gives you less will end up matching what you recorded right here. So you will be confirming through your calculations which one is a limiting reactant. And it should match your qualitative observations right here. So you're quantitatively determining you're quantitatively, just please laugh at me, rambling. You're quantitatively confirming your qualitative results. And I think I just said that wrong again. You're quantitatively you're confirming your qualitative results. There we go. Anyway, all of this is to show you how to calculate limiting reactants. Okay, so you're doing a test. You have to do it for both of your reactants. You have to convert them all the way to your grams of product for both of them, and that will confirm which one is the limiting reactant. Obviously, the one that gives you more CUS is your excess. So one of these will be your, one of these amounts and concentrations, right? The concentrations will be the same for all of them. It's the amounts, right? So one of these will be an excess, one of these will be limiting. So I have on here, show your calculations. I would say show me calculations for at least 2 of these. So I'm actually going to edit this. So on your version that you see here, show your calculations for five trials. So it can be the one that you use to determine the maximum, to confirm the maximum that you see here. It can be the one of ideal, which is the one that kind of has the exact amounts. There's no excess. Like I said, I'm really lenient with these types of open-ended questions, but pick the 2 that you like, that you want to confirm through the limiting reactant calculations, and show those to me, okay? Because I know it can get repetitive. So just show me 2 at least. And I would like to see this for all of it, for both of them, okay? This setup 2 times, that's 1 trial, and then again for the second trial, okay? Show me all your units, correct sig figs, everything, okay? Notice you only have 1 sig fig here, so that would, hint to you only 1 sig fig at the end. Okay, so that's about it for this lab. Feel free to ask me any questions. You will see this correct instructions on your lab, so don't worry. Um, and yeah, let me know if you have any questions. Email me if you would like an extension, anything like that. And thank you so much for watching.